Hi, I'm Amy Beaudet from the Alt-East store. Thank you for taking the time to watch our video series. The first video is an introduction to electricity basics. Its intention is to lay a foundation for learning about solar electric systems. We'll begin by going over terms and phrases commonly used in electricity, not just solar electricity. We'll also talk about why installing solar isn't just a license to use as much electricity as you want. You should still look into ways to conserve the amount of electricity you use. Solar isn't a silver bullet that solves everything. It's just one important step. Conservation is another. Let's start with basic terminology. To explain electricity, it is often compared to water to make it easier to understand the difference in terms. Volts, abbreviated as V or E for electromotive force, is the amount of potential energy. It is like the water pressure in your pipes. Amperes, more commonly called amps, abbreviated as A or sometimes I, it is the rate of current flow or electrical charge. It is often compared to water flow. Watts, abbreviated W or P for power, is the rate of power. It's how fast a device is using or making power. Watts equals volts times amps. Watts can be increased by increasing either the voltage or the amps. Like the amount of power a water turbine creates can be increased by increasing the water flow or the water pressure. Now that we've covered rates, let's move on to quantities. We'll continue with the water analogy. How much water do we have? Amp hours, or AH, is the quantity of amps over time. 1 amp hour equals running at 1 amp for 1 hour. Watt hours, or WH, is the quantity of power used or generated over time. 1 watt hour is 1 watt generated or used for an hour. You'll often see the phrase kilowatt hour. That is 1,000 watt hours. One of the most common mistakes at this point is confusing watts and watt hours. We'll switch from the water comparison to driving. Watts is the rate of power consumption, like miles per hour. How fast are you driving? Your speedometer tells you that. A watt meter shows you how fast a device is using power. A 60-watt device is drawing 3 times as much power as a 20-watt device. Watt hours is the quantity of power used, like miles. How far did you drive? Your odometer tells you that. Using a 60-watt device for 2 hours uses 120 watt hours. Now let's do the same with amps versus amp hours. Amps is the rate of electrical charge, like miles per gallon. How fast are you using the gas in your tank? An amp meter shows you how fast a device is drawing power. The lower the miles per gallon, the faster you're using the gas, and the sooner you'll run out of gas and be hitchhiking on the side of the road. Inversely, the higher the amps, the faster you are using the power in the battery, the sooner your battery will go dead. Amp hours is the amount of electrical charge, like gallons of gas. How much gas is in your tank? Your gas gauge tells you that. Deep cycle batteries, the type used in solar systems, are rated in both volts and amp hours. This tells you how much power the battery can store. What we are trying to do in a solar system is produce and sometimes store electrical energy. We'll want to keep in mind the basic principle that voltage will always flow from an object with a higher voltage to one with a lower voltage. In the case of a battery-based system, the voltage entering the battery needs to be higher than that of the battery in order to charge it. For simplicity, we often talk about a 12-volt solar system. In fact, none of the items in the system are actually 12 volts. We'll get more into this in later videos, but just remember that 12 volts is more of a category than an actual voltage. It's called nominal voltage. When connected, the solar panel is generally around 17 volts, and a full battery is around 14 volts. If the voltage output of the solar panel was equal to or less than the battery voltage, it would not be able to charge the battery. While a solar system can have just one panel and one battery, larger systems have multiple of both panels and batteries. The voltage and current output vary based on how they are wired together. Wiring panels in series, where the negative of one is wired to the positive of the other, results in the current staying the same, but the voltage increases. Two panels wired in parallel, where the two positives are wired together and the two negatives are wired together, result in the voltage staying the same and the current increasing. It's important to note that regardless of which way it's wired, the power, or watts, remains the same. Since watts equals volts times amps, it doesn't matter if it's in series or parallel. Likewise, when batteries are wired in series, their voltage increases, and when wired in parallel, amp hours are increased. You'll often see multiple rows of panels or batteries wired in series. Each row is a string. You can then wire the multiple strings in parallel. This allows you to get both higher voltage with series strings and higher amps or amp hours with the parallel wiring. In this example of two parallel rows of 4 batteries wired in series, it's called 2 strings of 4. You can see that wiring 4 12-volt batteries in series equals 48 volts, and wiring those 2 strings in parallel equals 160 amp hours. When you multiply that together, you get 7,680 watt hours. So now that we know the basic terms, let's talk about how much power you're using. Most electric companies give you a bill that shows how many kilowatt hours you used that month. They often will show you a 12-month history, so you can compare your usage month by month. You can detect seasonal trends from the bill. Higher summer usage usually indicates air conditioner or fans used, and higher winter bills are usually for electric heat or furnace fans. You may also notice that the charge for the actual electricity is just a fraction of the bill. You are also charged multiple fees and taxes for transmitting the power, funding special programs, and other services. Many electric companies charge a different rate based on how much power you use and what time of day it is used. When trying to figure out where all of your electricity is being used, note that different devices use electricity at different rates. Anything that makes heat and cold, like an AC or a water heater or stove, use a lot of power. In the past decade, a lot of work has been done to reduce the power consumption of most electronics. We'll go through some examples to see where this knowledge can help you save electricity. Energy Star has done a lot to bring awareness to consumers so they can make educated buying choices. Most items you buy today have an Energy Guide label available for it. With this label, you can compare different models to determine which model uses the least amount of power. You can see on the label where this particular model lies with comparable models with similar features, and on average how much electricity it will use in a year. Note that just because a device has an Energy Guide label doesn't mean that it's Energy Star rated. Having the Energy Star rating indicates that it is considered more energy efficient than other models. Always look for the Energy Star rating. So what's the big deal? I'm going to walk you through a couple of examples to see how this pertains to solar. Refrigerators have come a long way in this century. A typical fridge from before the year 2000 used about 850 kilowatt hours a year. An average Energy Star fridge these days uses less than 400 kilowatt hours a year. That's less than half the power from just 14 years earlier. You've all been hearing for years about swapping out your old incandescent light bulbs. A lot of people didn't like the CFL bulbs that were the only alternative at the time. These days, LEDs have come a long way, baby. Let's compare using 60-watt incandescent bulbs with 10-watt LEDs. Granted, LED bulbs cost at least 20 times more than an incandescent bulb, but stick with me. I'm going to show you how it makes sense to swap to an LED bulb next time your incandescent goes out. Both bulbs put out the same amount of light, both are dimmable, immediate on, and work in the cold. If you replaced 10 incandescent bulbs with LED bulbs. It would cost you about $100. But if you use those same bulbs for 4 hours a day, that would save 2,000 watt hours a day, or 730 kilowatt hours a year. At 11 cents a kilowatt hour, that's an $80 a year savings. You'd have those 10 bulbs paid for in savings in 15 months, and even less time in places with higher electricity rates like New England. So, you may still be wondering, what's this got to do with solar? If I make my own power with solar, I can run around my old inefficient fridge with all of my incandescent lights on for free. Well, sure, but let's step back to the size of your solar system you'd need. The less power you use, the less you need to make. The less you need to make, the smaller the system you need to buy. I'm not going to go into all of the math to determine what size solar system you need right now, but I'll give you the short answer. The example of swapping out just 10 light bulbs for $100 would require a solar system that is 650 watts smaller than providing the electricity for the old bulbs. So not only did those 10 bulbs save you $80 a year, but at an average installed cost of $4 a watt, you also saved about $2,600 on your solar system. Now let's talk about that nice new fridge you got. Swapping that old fridge with a new Energy Star fridge requires 400 watts less of solar. That's a $1,600 savings in solar. You could buy a nice new fridge and a few more new appliances with that, further increasing your savings. Now that you have the basic understanding, what's next? Look at your electric bill and see how much power you use each month. Look for seasonal trends to help you determine biggest use and perhaps your first steps to reduce that use. There are many resources available to help you find ways to reduce waste. You can start at energy.gov. Additionally, many electric companies have energy efficiency programs available for free. The Desire USA website will list rebates available in the USA, both federally and locally. If you'd like to learn more about solar, click here to watch the second in our video series. Thanks so much for watching. Also, check out our website, altstore.com, where we are making renewable doable.